Good morning, it's Dr. Long at CGC Delro. It's August 30th, 2019. This is the mind map for F103. From previous lessons, we talked about the JSIDS lattice that identified gaps, allowed us to develop solutions, to guide the development of those solutions in order to then resource ready forces that could then meet combatant commanders' requirements to execute their campaign plan. We walked through the process of going from strategy through requirements to capabilities to recommended solutions and JSIDs. Talked about determining if the changes we propose are a revolution in military affairs. We talked a little bit about what drives change. Is it new technology or new doctrine? The answer is yes. Sometimes it is one or the other, but you have to go all the way through .mil-PF to ensure that you've been systematic and disciplined to understand the environment. Then you can visualize the fight, and you can describe it, direct it, lead it, and then assess how you're doing. So UVIDLA works here as well as on the tactical fight. JSIDS, DAS, and PPBE, the three primary decision support systems that drive the creation of ready forces. And we talked about the importance of ADCON as the legal responsibility to provide Title X support to the forces by law from Congress with money to be spent the way they specify by law, not a command relationship. So it's really how the generating force does its job. On the left-hand side, you see a set of key terms that could come up or probably will come up in discussions in this part of the generating force. In the center, some of the big ideas that pull together a bunch of ideas for us. The flow chart of the 5 phases and the 3 milestone decisions. Pre-systems acquisition, then at milestone B we decide to acquire it. So then we begin developing the engineering and manufacturing base. Then after milestone C, we commit to a production and deployment schedule. We make a decision in there to go to full rate production, and we have an initial operating capability when the first increment is fielded and in place, ready to go. And then when we get to full operating capability, then how we decided we wanted to field it to the force has been completed, and then we've entered the sustainment phase where we're doing operations and support. So this is a sequential, iterative process whereby we go from good ideas until we prove it out. Milestone decision authorities allow us to progress to the next stages. A series of documents help us guide the next phase, becomes directive of how we're going to do it. So pre-systems acquisition, systems acquisition, and then sustainment. Those get expressed in buckets of money allocated to each one of those phases, expressed throughout the POM, the execution year, the budget year, the 5 years of the program, and then out in the planning phases, 7 to 25 years, we're thinking about those new ideas that are going to become concepts and then programs and then actually get resourced. So in the simplified flow chart of where we're at, JSID's got the requirements. CBA was the analytical engine that walked us through the rich description of the current environment where we are in the FAA. The functional needs assessment then defined the requirement. Functional solutions assessment then broke out those potential solutions into .mil-PF domains. Then we made a decision and documented it in the .mil-PF change, .mil-PF capabilities requirements, the DCR, which specified the material and non-material solutions we were going to commit to. The organizational solutions will go to the Force Design Update, F104, and then those that require material solutions go to DAS, and that's where we are now in F103. The other domains have proponents that build out their parts of the solutions. You'll talk about those in your paper. Then all those things come back together and then compete for resources and total army analysis, and then all of that gets managed through PPB&E in order to achieve our Title X functions for the generating force and the services to create those ready forces. So in the world of force management, which is going from strategy to combat-ready forces, force development is how you design, package, and propose those forces to do the work. And then force integration is, once you've decided to resource it, how you field it and then make it ready, and that's end-to-end force management. So the 5 phases of material solutions in DAS listed here. The reminder of the big 6 modernization priorities, the 3 requirements approvers, and then the 3 requirements lanes based on how urgent things are, the time frame involved, the document that's going to control it, and then how urgent is that actual need. When we talk about that acquisition program baseline, cost, schedule, and performance, this is a way to think about that. So in terms of performance, if I could ask for good, better, or best, and then how fast I want it, urgent, emergent, deliberate, so that's performance and time, and then the costs. You might see these little cost multipliers. These are just notional numbers. So the cheapest I can get it is if I only need it good enough, minimum mission essential, and I can be deliberate so that now I can be efficient. That's the cheapest, and at the lowest level of acceptable performance. That's what the KPPs do for us. Then maybe that might be the lowest factor. If I want the best possible as quickly as possible, then 2 times 2 to 4, that's going to be the most costly. And so this is a representation of how the blending of these 3 characteristics, these elements of the program baseline, drive costs. And that's part of the trade space in here. I must have it not later, than to deliver it, but the soonest I can get it, how good I want it, and then the cost driver. That's the relationship between those 3. I want to talk about the integrations and then come back to the details so you can kind of see the endpoints and what we're going to connect to. So Big 5 in the in the area of history, Big 5 in the airland battle was what we were doing in the 70s and 80s to respond to a world in which things weren't looking very good in 1973. We're going to go through some PEs in class where we take a look at World War II tank design between the German Panther and the American Sherman, and you've listened to the video on that already. There's a secondary idea in there where we don't necessarily need tanks to defeat tanks. You can go cheaper with tank destroyers, which are tank-like objects, but less capabilities, but in a defensive role, can be a very economic response in terms of cost and crew size to achieve the defensive effects that a tank would give you, but at a much cheaper cost. You'll see the Germans use that a lot in the Eastern Front. You can look at the M1A2 from the U.S. and the K1A1, which is a clone of the M1A2, but it uses a turbo diesel and has some other characteristics in the suspension and the elevation of the gun that makes it better suited for tank warfare in South Korea. And so there are different performances and different choices, but when you decide just at the mechanical level between a turbine and a diesel, it's different fuel, different consumption factors, different ranges, and then the vulnerability of the log tail is quite different. What it takes to sustain the turbine versus the diesel, which is much more forgiving but doesn't have as much horsepower as the turbine. So you might make the argument you need the turbine and the ability to dash across the plains of Europe. You're not going to have that kind of terrain in Korea. You're going to fight in a different way, and maybe that justifies the turbo diesel, and that gives you a different tank and different log. We'll talk a little bit about Civil War and use of cavalry at Gettysburg with Buford in the recon, screen, and guard role, bought time to let the infantry come in and seize the high ground in Gettysburg. The amazing Confederate cavalry under Jeb Stuart, though, was out conducting raids and far-sweeping cavalry jaunts, and Lee didn't have the recon and the information or that firepower that he needed to develop the situation, and so maybe Gettysburg unfolds in a different way if that cavalry is being used in a different way. So how you propose to use that material, how you're going to use those organizations and their roles and missions is an important part of this process. You can look at, in leadership, the effect of Guderian, a quartermaster and a signal officer who was responsible for most, if not all, of the German Panzer doctrine and training and tactics. Later in the war, after being amazing on the Eastern Front, became the Meister of all tanks for Germany and in 44 and 45, and was a major contributor to their capability to keep fighting. So the effect of that one guy and his idea on their entire armored force shaped a lot of World War II, so one person can make a difference. We see that in the Big Five and Ireland battle as well. You can see Patton in the same way between the wars. He came out of World War I with a certain idea how tanks should be done. He spent his own money and civilian equipment in the Louisiana maneuvers to kind of proof the principle of the armored division as a separate kind of force than the standard post-World War I infantry division, and had a lot to do with shaping our thinking on how to use armored forces to great effect. You can look in the Air Force at the effect of Billy Mitchell on the emergence of a certain kind of Air Force doctrine. It was Army Air Corps at the time, but there was a guy who was willing to go to the mat, and so that is an interesting case study in leadership and organizational as well as professional military ethic. If your strategy is the Maginot Line, you might want tanks of a certain kind to backstop infantry emplacements, so armored firepower in support of infantry and defense, versus a strategy of blitzkrieg gives you a different kind of doctrine and approach and tactics, and so the strategic choice you make can drive the tactical play and the kinds of material that you want. You can look at the strategies Rommel used in the desert and Rommel in Europe, driven by MET-TC and mission analysis to figure out how to employ it in the desert, willing to cut loose from his support base and venture out almost like war on the high seas, and who dares wins. And he came close in North Africa. And in Europe, having experienced Allied air power in the desert, had certain ideas about how armor ought to be used in defense of the continent, and there were serious decisions and discussions and disagreements about how to use those panzers to withstand the upcoming Allied invasion. And that strategic choice drove the characteristics of the fighting in 44. At the strategic level, the nation has to make a decision between things like, are we going to be a force projection army, or are we going to station forces forward to save time and not have to invest in strategic mobility? You can instead invest in specific capability. But if you're going to be force projection, you've got to invest in strategic mobility to solve the time equation of getting forces from the CONUS base to the theater that needs them. So there, you got to spend money and effort to do that. You can buy down some of that risk by use of pre-positioning to save some of those times and costs, but those are strategic choices that drive the kinds of equipment you need and the tactics you need and the kinds of campaign plans you have to put into place to acknowledge the strategic choices. There are strategic choices we make about the economy, how much you spend on R&D, what kinds of R&D, what do you promote, how do you establish a secure national industrial base to give you the internal capability to produce the material of war that you need. Things like rare earth metals, which are essential in high-tech solutions now have an economic consideration on the national security strategy. So just the things we want to buy can have connections all the way back to strategic choices that we make. In the area of tactics, what kind of role do you want that tank to play? Massed firepower to attack and be decisive? Do you want it to be light, fast, mobile, raiding, recon, destroying locks? Do you want it in a don't get decisively engaged but be able to guard or secure? Or do you need it as a distributed defensive protected firepower system to backstop your Maginot Line? So how you decide that you want to use those tanks, that tactical decision can drive the equipment that it is that you want. Then you got to answer questions like, well, how are we going to defeat his tanks? How good does our tank have to be to perform among those roles that we've chosen? How are you going to sustain that tank? And then how will that sustainment be threatened? And how will you protect that sustainment? So all that goes into your warfighting concept and the integration of warfighting functions, and then drives units that have to perform those functions. And then what levels of performance are you aiming for? What do you want, but what will you settle for? And how do you integrate that, train it, make it ready, and then how much of each? And that starts building back towards total Army analysis to make those decisions for resourcing. But how you answer those questions from the tactical fight have strategic implications across all of the PPBE years. So the difference between the M1 turbine and the JP8 versus the turbo diesel of the K1, the requirement to use the Red Ball Express in World War II to keep the momentum of the attack going when the sustainment concept was insufficient to keep it going. That was a creative response to the need to push fuel forward. We'll take a look in the tank PE about the effect of tank readiness rates on combat capability and why operational readiness rates are now part of the mandatory KPPs for all material solutions, because we realize that it's not any good if it doesn't work, and so we've got to do systems engineering for life cycle readiness. There's an interesting story about how the use of titanium to paint the insides of cylinder blocks raised the mean time between failure for strategic bomber engines from 50 hours to 500 hours, and just that little technical upgrade made strategic bombing feasible. There's an interesting story about how 200 sets of gauge blocks were smuggled out of Sweden in order to ensure that the industrial bases of the Allied countries could produce replaceable parts in all their distributed factories, and that could be brought together and fit. Without the precise engineering specification that's enabled by gauge blocks, you can't make interoperable parts. And Sweden had the world-class gauge blocks that allowed you to do that, to produce to tight specifications. And 200 of them had to get smuggled out past the Nazi border guards in order to really unleash the power of the industrial base and the economic engine. So a very interesting story there. Well, if those are some of the connections to the other departments, then some of the language and the key terms that we'll end up using when we talk about DASA, cost, schedule, and performance, key performance parameters, those measurable levels of performance that we're going to use to consider real choices within the trade space and then evaluate the performance of different proposals. ACAT acquisition category that drives the level of authority that it takes to approve going through the milestones and to manage programs by law. Material and non-material solutions coming out of JSIDS, initial capabilities document, capabilities development document. Got to be able to explain those. So these are all layups. You need, I think, you'd want to have a 30-second or a minute-long speech on all of these. The problem, but also opportunity of COTS solutions, commercial off-the-shelf. gives you something right away, but now when you start thinking about Army life cycle maintenance costs and sustainability, you get some real challenges in there. Program of record, when it gets through milestone B and is now documented in the POM and has money allocated against it, we're going to build it out. That's really an important milestone decision right there. Full rate production, initial operating capability, full operational capability, the role of, those are all decisions and quantities and management packages, if you will. Army Futures Command role, the 8 cross-functional teams, how we do rapid acquisition with those requirements, lanes, the roles and functions of the Army Acquisition Executive and the JROC and the AROC, I should add. The Big Six and how that compares to the Big Five. The program, project, and project managers in the Acquisition Corps that are managing all of this equipment. The operational needs statement approved by and validated by the G357, which is how we get these urgent requirements delivered. Technology readiness levels, 9 of them. It describes how mature that piece of technology is, and that really drives where it is in the life cycle, and we want it to be of a certain level in order to justify moving past or through that gate, that milestone into the next phase. One of the downfalls of the future combat system, a system of systems. They had so many systems that had to work together, and the combined integrated technology readiness levels of all of them just represented unacceptable risk and made it unfeasible. Trade space is that area in which we've met the minimum performance parameters of the KPPs and within certain time frames and costs, and now we can trade off different solutions in deciding what we're going to actually field. How we go from vision to concepts to doctrine and the implications on materiel. Talked a little bit about that in the vision and concept level. You have to have that sorted out so you can start getting those material solutions designed and delivered by the time the doctrine's ready. And lifecycle costs is now part of this solution. It's not just what it takes to produce it, but also what it takes to maintain it over the life cycle. And when we get it right, most of the money gets spent out in here because it's a solution that lasts a long time. There's a cost of adaptability, that I can build something with efficiency and get the best cost, but as soon as I need to alter it, now it costs money to start adapting that process. And if I didn't build adaptability in, the cost of adapting it is great. But I drive up my initial costs if I'm building in the potential for further adaptability, like modular frames. So I have to build placeholders in the motherboard or in the hull for new material that haven't even developed yet. That there's a cost to all that. So that's not the most efficient way to buy today's solution, but over the life cycle cost of the machine, buying adaptability today can save future costs, and it's almost always the case. You see that in the world of, HTML and open systems architecture for computers. So you can build modules that, as long as they can comply with the existing standards, then you can build it into the legacy systems. When you decide that this new revolutionary design can no longer accommodate legacy systems, you've made a real can't-go-back decision and just drove up a bunch of costs for how to design to new specifications. So those international standards organizations like ISO standards are really important. Things like modular 20-foot containers. That's a material solution that revolutionized global supply chains. And everybody could design ships and airplanes and trains to carry those because of the standardization. That allowed us to be adaptable with new platforms because they had a standard to manage to or to engineer to. So that gets into the whole efficiency versus effectiveness discussion as well. When we think about force modernization or force design, you can think about revolutions versus evolutions. Evolutionary micro improvements to existing structure, the way Toyota in their quality work circles takes that base design and then each of the next 4 years improves the manufacturability and the quality and incorporates new insights from field experience. And so they do evolutionary development of product cycles. But then they also do revolutionary design every 4 years. Once they've got one out the door, the design team takes over with a fresh blank sheet of paper and starts designing from scratch the new car model that's going to come out in 4 years based on an estimate of what's technologically going to be feasible in 4 years. It's like they're using the TRLs, that tech readiness level, to decide what things are probably or should be in hand so we can incorporate those new revolutionary designs. And that allows them to leverage these new capabilities and not get bound by the legacy platforms from the previous cycle. So they do a combination of evolutionary and revolutionary development. And that's been so successful in the world of transportation capability manufacturing that that's an idea that we're looking to see how we can do that inside our acquisition system, both evolutionary and revolutionary. There's a cost of maintaining parallel, simultaneous, nested development, but compare that to the probability of getting it exactly right for 30 years and then designing to that. Can you really anticipate that? No. So the combination of evolutionary and revolutionary in the Toyota production system has some interesting implications. Well, at the strategic level, when you've got to consider your posture with allies and partners and international standards, if you want to integrate all of your allies into a mutually supportive network of cooperative defense, there are consequences to changing that policy. You can read General Mattis's ideas on that, recently published. So those are strategic choices that come out of the NSS and impact the NDS and the NMS from strategy. And those have consequences in our acquisition as well. A policy to buy American has legal, economic, and procedural implications for the entire acquisition corps. Had an officer last year do a very interesting MMAS on that to figure out how to adapt to changes in strategic policy at the acquisition level. If you're interested in that at all, she did brilliant work on that in the MMAS, and I can point you to that. So those are some of the terms of art and the key concepts that could be used to build out answers or deepen your understanding of some of these two-dimensional models. And then the connections to the other departmental contact, these are like case studies of how this stuff pulls together and is manifested in the world, and some of the challenges in each of those. But I want you to see that force management naturally and specifically must incorporate all of those insights in order to get this series of successive approximations correct in order to field a force that's ready today, tomorrow, and in the future to meet the warfighting commander's needs. And that's what we're all about, is satisfying those combatant commanders' requirements. And so JSIDS is how we turn that into systematic professional solutions. And then DAS is how we build out those material solutions, and we manage that across the PP, B, and E, and that's the intersection of those three decision support systems. So thanks so much for your kind attention. This is good Army work right here. This is hard field grade officer work. And finding your role in all this is key. You could be a battalion XO trying to make this happen in your unit. You could be a division staff officer trying to integrate those force integration functional areas and how you field this new package across all the units in the division. You might be a DA staff officer or a proponent or in a MACOM trying to figure out how to arrange those resources to come over the multiple years that it's going to take to field the force. You might be on a ASCC staff somewhere trying to help develop the specific ONs that are going to flow up through the GCC to come back to the building in order to get satisfied urgently or emergently or deliberately, and maybe assigned to a unit or a higher headquarters that's going to be tasked to come to the CFTs at Futures Command to help get the end user's requirements more clearly understood earlier in the design process by the generating force, so that we start with a better product closer to what the customer actually needs, so that we don't spin our wheels in the earlier phases of the acquisition process. You might be in a CDID trying to turn lessons learned into statements of requirements that will participate in both JCIDs and DAS to get these solutions. You might be in a unit tasked to conduct field experiments to comment on whether or not the capability that's offered in this prototype could actually be of use if we end up building it in a tactically resilient way. So you might have to use your vision to look into the future to see how this clunky piece of equipment might actually give you a useful capability if we decide to move it into tactical development and ruggedize it and streamline it and shrink it and make it robust and add the capabilities that you want to see. So we've got to learn how to think in these ways so that we can activate the supply chain and the design chain to get the things that we need. And so this lesson and all these ideas are fully integrated from how we go from strategy to wartime readiness in units, forward deployed or in the support base. And this is the connecting gearbox. This is the operational art that connects those ends, ways, and means. I should probably add that up there into history and strategy, shouldn't we? All right, that's enough. Take good care, and we'll see you in the classroom.